So yeah, unfortunately, nakat yung huling video ko because biglang bumigay yung internet. Salamat, Converge. But fortunately, sakto naman siya natapos sa uh, explanation ko on exercise 3. So we now move on to week 8 exercises, which are focused on the three data structures, specifically the binary search tree and the maximum heap. Now, before going there, actually, I think we can wait. Okay, so for the binary search tree, hopefully familiar naman kayo kung ano ang binary search tree. Punta tayo sa ating favorite website, visual.net, and you can actually find, as expected, a binary search tree visualization over here. So in a binary search tree, lahat ng elements sa left ng isang node is less than that node, and lahat ng elements sa right ay greater than that node. So that means when we want to insert an element, let's say 5, you'd expect na yung 5, mapupunta siya sa left side ng 9. And then when we insert, say 15, mapupunta naman siya sa right side 9. So that is a binary search tree. So ano kailangan gawin? So there is this partial implementation, and you just have to focus actually on these two parts here na maraming comments. So part A and part B. So for part A, you are to complete the implementation of the insert function, wherein given this BST node, i-insert ko yung certain value into it. So meron ng actually nandyan. So if the value is less than the data, so as hinted here sa if statement, we go to the left of the tree. Otherwise, we go to the right. Dito sa baba. And then there are two cases when we insert sa left or insert sa right. That would be if pag merong isang element. So notice here na kinocall si insert ng BS3 na class for the root node. That means when we insert, let's say 82, 82 gets inserted to the root. Basically, ang i-call na function ay insert 82 kay root node. So what does the root node do? So si 82 mas malaki kay 17, so it goes to the right. And since yung right subtree natin exists, anong gagawin niya? Ipapasa niya si 82 kay 90. Si 90 din, ipapasa niya si 82 kay 87. And then si 87, ipapasa niya kay 80. Si 80 naman, since mas malaki pa rin si 82 sa kanya, ipapasa niya siya kay 84. And si 84, it should go to its left, and wala pa siyang left na element. So dun pa lang siya ma-insert. So, ayun. Hopefully nakikita niyo yung parang recursive nature, yeah? Since a child of a tree or a node, the child of a node na tree is also another tree. It's also another node with its own subtrees. So there are two ways of implementing it, of course. Meron tayong iterative way na pwede kang mag-loop. Mag-loop ka hanggang makarating ka doon sa 84. Or there is another implementation na iterative, na recursive, na inserting it to 17 means inserting it to 90. Inserting it to 90 means inserting it to 87. And inserting it to 87 means inserting it to 80, and so on and so forth. So that is part A. Part B naman over here is to implement a recursive form of BST BS3 print. So we need to return the contents of the binary search tree in a sorted order. So if you've been following the material, you should know that meron tayong apat na traversals, yung pre-order, in-order, post-order, and then yung breadth first search. So you should know by now which of these traversals yung magre-result into a sorted list. So you can try naman each of them and tignan mo kung alin dun yung magiging sorted na list. So for example, pag nag-in-order traversal ako, ang magiging result ng list ay yung pag-visit. I don't think papakita niya ba? Yeah. So, nakita niyo ba yung traversal? Nasundan niyo ba? Pag hollow siya, ibig sabihin is loaded na yung node sa stack pero hindi pa siya nabivisit talaga. So, if you notice kung aling element yung unang visit and a specific order, you should know which type of traversal you should implement for this part. So that is for the BS3 implementation. Okay. So next one is the Max Heap implementation. And actually, you can actually learn the whole curriculum of one-to-one using this website. Hindi naman lahat, pero mostly on data structures. Okay, so ang ating heap ay implemented. So yung binary search tree kanina implemented more like a linked list wherein meron tayong mga pointers. So our max heap naman is implemented more like an array since ang ating heap ay always full, ang kanyang levels ay parating full, we are guaranteed na we can easily predict yung size niya, basically. And we can actually, ayun nga, for example here, meron akong 6 elements. So I can have a 6-element na array na yung first node ko is index 1. Yung children niya will be index 2 and 3. Si index 2, ang children niya will be index 4 and 5. And si index 3 ay magiging children niya is si node 6 and then possibly node 7. So let's just insert another node there. So yeah, so node 7. So what you have to implement for this exercise are, I think, 3 things. So the first part is to define, given the index of a certain node, ano yung index ng kanyang left child. So you can actually predict this. So pag si 40 nagkaroon ng child, ano sa tingin nyo yung dapat maging index ng kanyang child? So nag-insert ako, index 8. Ano kaya yung relate nun sa index 40? So when I look at index number 4, since alam ko na index number 4 siya, paano ko nalaman na index 8 yung kanyang child? Without even looking at the numbers, si index 7, ang left child niya, you can expect it. May mga hula ba kayo? You can expect it at index 14. So, dagdagan lang natin hanggang sige, yun sa 6 na lang, index 12. Index 12. Galing ko, na-predict ko. So, ayan. Similarly, ano yung index ng right child given yung index ng parent? So, 12 ito. So yung index ng susunod should be 13. And din yung right subchild ni index number 6. Then lastly, kung meron tayong for the children, meron tayong for the parent. So looking at index 11, alam natin dapat na yung parent niya would be index 5. Looking at index 4, alam dapat natin yung parent niya is index 2. So ano yung relationship between the indices of the parents and the children? So this would usually take some addition and multiplication, maybe division, maybe even subtraction. So hindi naman siguro kailangan ng exponentiation. So ayun. So after that, so that's part A. So the next thing you need to do is to implement the extract operation. So basically, yun na basically yung comments. So the first thing to do is to pop the top node and store its value dito kay result. So dito sa binary tree, if you want to visualize it, when we run the extract max operation, the first thing to do is actually tatanggalin si 88 kasi siya yung nasa root. So ano yung next na gagawin? So ayun, internal ito, kailangan mo i-modify yung size ng binary heap mo. So ano dapat mangyayari kay size? Lalaki ba siya? Liliit ba siya? Nag-extract tayo. So ano dapat yung mangyayari sa kanya? So kung may naman pa yung heap, ano pa ba rin dapat gawin? So we can look at the visualization here. You can see that the last element actually replaces the top node. So bakit yun yung gagawin? Kasi yun yung pinaka madali. So recall na gumagamit tayo ng array na implementation. And in order for us to remove an element, pag gusto ko ilipat si index 2 or si index 3 doon, that will be way more complicated when we compare it to just getting the last element dun sa array tapos ilagay ko siya sa umpisa. And what I need to do then, since binary heap to, is to heapify yung ating list. So what does heapify mean? So meron tayong, yung other word sa kanya is apparently bubbling up or bubbling down. So since si 14 nasa taas na siya, nowhere to go but down. So anong ginagawa ng bubble down? So kung titingnan nyo dito sa na-implement dito, we first get the indices of the left and right child of the current node. And then if within boundaries, yung left and right is pupunta tayo dito sa else. So basically yung case na to is wala siyang right child, so si left child lang yun i-compare ko. And di ba in a heap data structure, yung topmost element or yung ating parent should be always greater than its children. So when we want to bubble down, we have to compare the certain element with its children. So si 14, ang current na children niya is 61 and 83. So we choose whichever is higher. Kasi pag kinuha natin yung maliit, 61, pag pinagpalit ko sa kanya si 14, mas maliit naman si 61 kay 83. So we don't get that heap property. Pero pag sinwitch natin si 83 at saka si 14, ayun, yung parent is now larger than its children. And then yung next step doon is to repeat the process. Pero now, yung index ni 14 ay index 3 na. So, nag-update yung index na dito. So, magsaswap yung nodes and then do the bubble down operation for that index. So, and it goes on hanggang maka-reach sa point na wala na siyang mapagsaswapan. So, that is your extract operation. Now, sa insert operation naman, let's say, maglagay tayo ng malaking number. When we insert, recall, array implementation siya. So where is it easiest to insert? Sa dulo ng list. And sa dulo ng list, susundan niya lang basically kung ano yung index ng huling element, dun na siya sa susunod, index 13. And automatically, because of how we set up the binary heap, it should be understood na yung parent ni 13 ay si 6. So similar sa ginawa natin kanina, bubble down, ngayon si 91 nagsa-start sa baba. So there's nowhere to go but up. So we compare 91 to its parent. Eh, di ba nga heap? So dapat mas malaki yung element na nasa taas. So we switch 91 and 58 para umakyat si 91. And then we repeat the operation. But now, si 91, ang index niya is 6. So ang parent niya is 3. So we compare 91 and 72 and mas malaki pa rin siya. So magbo-bubble up lang siya hanggang marating niya yung dulo sa taas. And lo and behold, si 91 na yung pinakamataas nating element. And siya nga is greater than all of the elements below it. So that will be, so yung part B is yung extract and part C, yung insert. So yun lang naman yung kailangan nyo i-modify. So basically, fill in the blanks over here. And then, dagdagan mo na lang ng lines dito. So do your implementation of the extract operation. So usually may kita mo dito, bubble X starting from IDK. So you should be able to find out for yourself. So actually, baka mag-inggit yung ibang klase. Ang dami ko na sinabi sa inyo. So that will be all for the week 8 na exercises. Hopefully, you understand na yung sa week 11 na exercises. If not, just let me know. And if ever may mga questions kayo na hindi ko nasagot with this video, just let me know. So again, I apologize for not being able to meet you today or later. And it would have been better if yung questions nyo agad ko ma-address, pero I think this is, hindi ko naman to gagawin pag hindi kailangan. So, thank you very much and have a good day.